So throughout the program, we've been looking at this issue of quantum technology, that strange world of science where reality really is turned upside down. Of course, it has huge implications and applications for our world as well, from driving a car to how we fight wars and medicine and science. Dr. Brad McKay is here to look at the way it'll affect our health, Brad, and the way that we relate to our doctors. Are we seeing quantum technology have an impact already?
Well, at the moment, we're using big data to track things like epidemics. So during the Ebola epidemic from 2014 to 2016, a lot of the organisations around the world used social media to really see where things were spreading. So by seeing what people were posting, whether it was things like fever or infection or diarrhoea, we're able to sort of like focus on those areas where we're seeing people talking about it online and seeing where the Ebola was sort of going to be fighting next. But the whole thing is that it's more complicated than that. You've got everybody else in the world talking about it. There's all of these rumours that are spreading around the world. There's all this fake news. So from looking at these algorithms, we've really got to sort of like tone it in and see through the noise and find out where these little elements are popping up.
And of course, we still don't know, do we, exactly what the implications are going to be, because we still don't know exactly what it's all about, really, to be honest. It's recreating itself.
Well, hopefully the big picture will be able to have a lot more power behind the computers and get that information.
And so when we're talking about quantum computing, let's break it down and look at direct impact on health. What sort of illnesses, diseases will it help in being able to diagnose quickly?
Yeah, well, skin lesions are a big issue in Australia. So we already have skin apps where you can take a photo of your skin lesion that you're worried about and send that off to either a dermatologist or to a robot to have a look at it and see if it's something to worry about or not. So at the moment, the technology isn't quite there as far as computing is going. Dermatologists still just are a little bit better than robots at this point of time. But with quantum computing, like the next step, we'll be seeing that computers will actually be better at pattern recognition, identifying if this is a lesion to be worried about or if it's something that's quite safe. So when we're getting better than doctors that have been doing it for 40 years, that's a game changer.
Out of a job here, are you?
No, we still need people to cut it out. So that's one of the benefits.
I suppose that's the next step, isn't it? Do you actually see a robot being able to perform the surgery?
Well, we've got robots that are already performing operations.
But with a doctor, of course.
But with a doctor in the next room. Yeah.
Now, in terms of being able to look at drugs, for instance, and what people can take and the impact that's going to have, there are applications and implications there too, aren't there?
Yeah, if you're trying to design a drug, it's like a long piece of string or pasta shoved into a pasta bowl, but then the pasta's got to be in exactly the right shape to activate a receptor that it comes in contact with. So at the moment, we're just sort of like stirring the bowl and trying to get the pasta into the right shape by chance. But if we actually have better technology and better computing power, we can put everything through a simulator, find out exactly which shape will be the best match for the receptor, and then that could just shave billions of dollars and years of research for new drugs.
So it's much quicker and much more accurate.
Yes.
The other thing is map. We know we've mapped the human genome, being able to the impact that that's had. This will be even better again, won't it? And being able to do that and to identify these things more quickly. Yeah,
we're talking all about precision medicine. So say for an antidepressant, for example, often people are trying 6 or 7 different medications until they find the right one. So if we're able to map your genome within 24 hours these days for about $1,000, it's a lot cheaper than what it was even 10 years ago. If we're able to identify what your genome is, find out what drug is likely to work best for you, look at interactions that can possibly happen with other medications, look at your metabolism, adjust that with your lifestyle and your environment, put all these things together and crunch that whole number, we can find the right pill, the right medication that's going to work for you.
So when we're looking at this, more broadly, we heard this earlier, but the whole question of quantum technology is seen as a second revolution. That's what they're saying. It's how to apply quantum physics in different ways. Do you see it in the same way as in medicine as a revolutionary change?
Well, we're still waiting to see what happens. So there's all these promises of the future.
A lot of it's science fiction, I suppose, as well. But
definitely. But if we're getting the technology to get faster, if we're getting it to be smaller, if it's going to take less electricity to run it, then then we can also have like a laboratory sitting on my desk at work. So I could get a swab. If you're coming in with either a flu or a bacterial infection, I can swab some snot, put it into the machine, and then test it, look at the DNA, and then tell you within a few minutes like whether you need antibiotics or not, and if you do, which antibiotic is going to work.
Just want a final question too. A lot of this is projecting, isn't it? This is what's going to happen in the future. The things that you've described today, being able to identify which drugs will work, quicker diagnosis of problems, particularly issues with skin. Are we seeing this now? How quickly are we going to be able to see the potential of quantum technology?
Yeah, well, when I was a kid, my first computer was a ZX Spectrum, where I had to put cassette tapes in and then load it up for half an hour to get a game to work. So I wouldn't have imagined at that stage what computers would be like now. And we're really seeing this as the next revolution. Like this is the next sort of step where we can crank things up. So it's like we're playing with a ZX Spectrum at the moment, and we don't know what the power is from here.
Don't know what the world's going to look like from here. That's a whole other question. Good to talk to you, Brad. Thank you again.
Same here.